Hi, Geometry. We're going to be doing section 4.2 today, transversals and parallel lines. So first, for a couple definitions. Anytime you have two lines, remember lines go to infinity, so we put arrows, and you have a third line that crosses through both of them, that's the transversal. So we have two lines and the transversal crosses through both. Okay. Now what we're going to be working on today and for the next couple days is those two lines. And how do we show whether or not they are parallel? So the real life example they have here is this fence where we've got actually multiple lines, but we'll just pick two of them. And this cross beam or crossbar. Now, what does that crossbar serve in real life? It locks it in so that that gate stays rectangular instead of slipping into a parallelogram. But so it keeps those two lines perfectly square and parallel. All right, now let's take a look over here. There are four types of angle pairs we're going to be talking about in this section. The first is corresponding. Corresponding are in corresponding places or the same place on each of our two lines. So if I'm looking at angle 1 out of this group of four angles at that intersection, angle 1 is in the top left. So when I come down to line Q, I'm looking for the angle also in the top left. Another set might be 3 and 7, or 4 and 8, or 2 and 6. There are four sets of corresponding angles on any of these scenarios of three lines. Same side interior means the same, means just what it says. Same side means they're going to be on the same side of the transversal. So let's pick angle 4, right? Interior, so they're both on the inside, in between my set of two lines. So 4 and 5, those are same side interior angles. 3 and 6 would be the other set. All right. Alternate interior. Alternate means opposite sides or alternate sides of that transversal. Interior on the inside. So if I look at angle 4 on the inside, the alternate interior would be angle 6. The other option there is 3 and 5 are also alternate interior. And my last one, alternate exterior angles. So exterior, I'm looking outside those two parallel lines. And alternate, opposite sides. So if I look at angle 2, the alternate exterior, so alternate side of the transversal, but also outside, is 8, 2 and 8. The other set is 1 and 7. The key thing with all four of my angle pair sets is one angle needs to be on the top line or the first line, and one angle needs to be on the second line. You cannot have both angles in the pair be on the same line. So I couldn't look at angle 1 and 2. Those are not alternate exterior because they're both on line P. All right, let's jump into an example here. Same side interior angles postulate. So what this is going to say is that if two parallel lines, so now we're still looking at this scenario, but we know that P and Q are parallel. If those two lines are parallel, they're crossed by a transversal, the same side interior angles are supplementary. So same side interior, for example, 4 and 5, are supplementary. That means that those two angles will add to 180 degrees. Okay? That is true always. So if the lines are parallel, angle 4 and 5 add to 180 degrees, and the other set, angles 3 and 6, will also add to 180 degrees. Example 1 is going to ask us to prove the alternate interior angles theorem. So this is telling us two parallel lines cut by a transversal, so P and Q are parallel, We want to show that the pairs of alternate interior angles, have the same measure so that they're equal. So we're going to pick a set. They gave us that the two lines are parallel. We want to prove that angle 3 and angle 5 are congruent, that they have the same measurement. So let's take a look here. Angle, or P and Q are parallel. That was given to us. So we're just going to write given for that reason. Our next statement, angle 3 and angle 6 are supplementary. 3 and 6 are supplementary. That's that rule we just learned. Same side, interior. I'm going to abbreviate a few things because I write large. Angles, theorem. A theorem, if you haven't, is like a rule, but in math we can't call it a rule because it just takes one example for us to be proven wrong. Okay, so we've used given. We've used, sorry, not a that one is a postulate. We're proving a theorem. In this case, for this problem, they've given us a reason bank. So we're going to end up using all these reasons. So we know that they're supplementary. Next step is that, what does supplementary mean? It means that angle 3 plus angle 6 is 180 degrees. That is the definition of supplementary angles. All right, so we're set there. We know that those two add together. Now, the next rule they gave us said that angle 5 and angle 6 are supplementary. That's these two here. Well, how do I know that they're supplementary? That's my linear pair theorem, right? Because they're a linear pair, they're right next to each other. So we're actually going to use linear pair theorem for a few here. And THM is an abbreviation for theorem. Now, what does the linear pair theorem say? It says that they are supplementary. And coming back to number 6, well, that's using the same rule we did for number 3. Definition of supplementary angles. Okay, so we now have two equations that both equal 180 degrees. We can substitute into and set them each equal to each other. If they both equal 180 degrees, I can replace the 180 with one of the other equations. That is the substitution property of equality. Again, using some shorthand here so I can fit it in there. And last step, notice they both have the measure of angle 6. So I can subtract the measure of angle 6 from both sides. They cancel out. And I'm left with measure of angle 5 equals measure of angle 3 equals measure of angle 5. I use the subtraction property to get there. The subtraction property of equality. And now I have ended up with what they asked me to prove, and I'm done. We'll practice proofs more in class. I'll talk to you guys later.